Welcome to the course MCDM techniques using R. So, in previous few lectures we have been discussing this particular specific technique called ELECTRE. So, let us do a quick recap of what we have discussed till now and then we will move forward. So, this part we have discussed the ELECTRE, it means elimination and choice expressing reality method. We talked about that here also pairwise comparisons are involved, but the methodology and the algorithm is quite different. Slightly complex techniques, several technical parameters and the steps that are involved are slightly complex. For different kinds of problem there are different kind of ELECTRE methods. So, all this part was discussed in the previous lectures. We talked about the outranking relation where we denote it using A capital S B, where A and B are both alternatives. Then this particular this particular notation means A S B means that A is at least as good as B. This is an example of an outranking relation. So, we measure this outranking relation using the outranking degree, which we indicate which we denote using capital S in parenthesis A comma B, where A and B being two alternatives. So, all this part was discussed. Then we talked about the concordance degree and the discordance degree. So, this part was also discussed. Then we talked about different scenarios and how the concordance degree, the partial concordance degree, how this is going to be computed, and we also discussed the same thing through this particular graph where we talked about how partial concordance degree denoted by Ci of in parenthesis A comma B is actually computed. Then we talked about the global concordance degree, and which is nothing but the weighted sum of all the partial concordance degrees. Then we talked about the partial discordance degree. So, this was also discussed. We also discussed the scenarios how this is going to be computed based on the given parameters. In the concordance the preference and indifference threshold are taken into account, and in discordance the veto threshold as well as the preference threshold are taken into account. So, this particular graphic also, through this graphic we talked about the partial discordance degree in previous few lectures. Then we talked about the global outranking degree, which is based on the summarization of these two degrees which is which are concordance and discordance degrees. Then we also slightly briefly discussed about the next phase of ELECTRE, that is distillation procedure. So, in this we talked about that there are two procedures within this, ascending and descending distillation procedures, and a final ranking is generated based on the two pre-orders which are generated using these two procedures. So, this part we were able to cover in previous few lectures. So, now in this particular lecture we will start through an exercise. So, we will go through a particular problem, a particular decision problem, and do our modeling in R environment using R Studio, and then we will also try to understand the underlying mathematics behind all those computations. So, that part also we will try to cover in this lecture and in the coming lecture as well. But let us first start with the this particular exercise, that is. So, goal of this particular decision problem is ranking of 10 French cars, and alternatives and criteria, those details we will discuss in the R Studio. So, let us open R Studio. So, here the package that we the package that we require is called Outranking Tools package. So, just like in previous lectures where we covered an R exercise for AHP method. So, just like there we first installed a particular package MCDA and AHP package. So, similarly here also you can complete your installation step before moving ahead. So, you will have to type install.packages, and then you will have to type within the parenthesis within the double quotes you will have to type the name of this particular package as given here. So, this name this as it is with because this is case sensitive. So, therefore, in the install.packages function within the double quotes you have to type this, and your installation will install and will have the required functionality for us to go ahead and do our ELECTRE modeling. So, let us come back to the problem here. So, the example that we are taking is ranking of French cars. So, that is the goal for this decision problem. Then as you can see the goal is mentioned here in the comment section. So, as we saw in the previous lecture when we did an exercise using R, the comments are actually using the hash symbol, we comment out all the points that we have to write apart from the code. So, you can see here goal is running of French cars, and criteria we have 7 criteria that we are going to consider to achieve this goal. So, these are the 7 criteria. So, because this is related to car and we are to perform a ranking exercise of French cars. So, you can see here these are some of the criteria that we are going to consider here. So, these are related to car performance and acceleration and other things. So, they are mentioned here, top speed and all those things. So, different aspects of cars, they have been considered under these 7 criteria. Then we have 10 alternatives. So, these are the code names for 10 French cars that we are going to consider in this particular exercise. So, these are the names of alternatives. So, we have 7 criteria to consider and 10 alternatives. So, first thing that we are going to do is first we will name the criteria. So, you can always create a you can always create this kind of character vector in the R Studio and the R environment. So, criteria and C is the function that can be used to create this particular vector or variable. So, you can see all the criteria names are part of this line of code. So, C is the function which is going to concatenate all this So, C is the function which is going to do a concatenate which is going to combine all these character strings. More information on this particular function you can always refer the help panel. So, if you just type C here and you will get more detail. See, combine values into vector or list. So, you can look at more details here. The function and different arguments which are part of this function you can see here. So, actually the values which are to be combined are to be passed as arguments. If you are interested looking few examples you can always look here. So, few examples are always given in this help page. So, you can look for example this 1 to 7 1 comma 7 to 9. So, this particular these particular values can be combined using this particular function. So, combine values into a vector or list. So, what we have done, the names of criteria that we are trying to combine using this particular line of code. So, let us run this and immediately you would see that in the environment panel here you would see a criteria variable has been created, which is actually a character vector and having 7 values, as you can see here, and the values are also mentioned here. So, first we need to get the names and create this, then we need to specify the criteria weights. So, you can see here again we are using the same function C and to combine these values. So, now this time these values are these are quantitative values, you can see. So, corresponding to each of the criterion, one particular weight has been initialized. So, you can see 0.3, 0.1, 0.3, 0.2, then 0.1 and then 0.2 and 0.1. So, corresponding to we have 7 values. So, corresponding to each of the criteria we have to give one value everywhere. So, let us execute this line and you would see the criteria weights. This is a numerical vector consisting of all the numeric values here. So, you can see the environment section we have this. So, now we have created these two vectors, character vector for criteria names and then the numeric vector for the criteria weights. Now, as we talked about in the previous lecture that we need to set the preference direction for these criteria, whether we would like to minimize or maximize the criteria. So, that particular that particular aspect also is to be required here as input. So, we are going to create another variable called min max criteria. So, here we have indicated for each criteria whether it is to be minimized or maximized. So, you can see first criteria, that is pricks, it is to be minimized, then second criteria, that is V max, it is to be maximized, then C 120 is minimized, then C off is to be maximized, then acceleration is to be minimized, and then the two other variables they are to be minimized as well. So, for corresponding to each criteria, each criterion that is there in the given set of criteria, we have to we have to indicate our preference direction. So, let us execute this line of code and we will create another variable. So, you can see another character vector has been created if you look at the environment section here. So, another character vector has been created and having 7 values for each of the criteria. So, you can see these values have been initialized. Now, once this part is covered, then we will come back to the alternatives. So, all the information, the names and the input initial inputs initialization for criteria has been done. Now, we will start with creating a vector for the names of alternatives. So, here again same function C is being used. Now, this time character values are being combined to create a character vector. So, let us compute this, execute this line and we will get this. You can see in the environment section another character vector has been created, which is alternatives, and there are 10 values which are part of this character vector. So, you can see the names of alternatives have been allocated. So, once this is done, then we can move ahead and then we can create another another important aspect of ELECTRE, where we have to give the performance numbers for all the alternatives with respect to each criteria. So, here the matrix that we are going to compute, so each row is going to correspond to an alternative. So, in each of the alternatives, in each of the row we will have one alternative. So, since in this decision problem we have 10 alternatives, so therefore, we are going to create 10 rows and each column is going to correspond to criterion. So, since we have 7 criteria, therefore, we are going to create 7 columns. So, 10 into 7 matrix we are going to create, and cell of each cell of this particular 10 cross 7 matrix is going to have a value related to performance. So, let us create this matrix. So, now there are different mechanisms in our environment to create this particular matrix. So, just like in the AHP exercise that we did, where we had used the matrix function and the C function, that is combined function, to actually create the matrix. So, here again we are going to use the same thing. Now, at this point you need to understand the matrix function in more detail. So, in the last exercise for ASP that we did in R, we did not talk much about the matrix function. So, let us understand this function as well, because this is one function that we might be using quite often. So, you can see the matrix, this is part of the base package here. You can see the name of the package here. So, this is part of the base package, and the matrix creates a matrix from given set of values. So, so of course, if you look at the usage here, then you can see the first argument that is passed in this particular matrix function is data. So, first we need to pass on this data that we are going to use to generate this matrix, then number of rows and number of column, and then this is another important argument here is by row, that is initialized as a false, that is default value. So, number of row, for example, in this case we are going to have 10 rows, and columns we are going to have 7. So, you can see here in the code that we have here a number of row is initialized as 10 and number of column is initialized as 7. Then we can also have another argument called dim names, which is nothing but dimension names. So, in this case, because this is a matrix that we are going to generate, it is between alternatives in the row side, row dimension, and the criteria on the column side. So, therefore, we can use this dim names argument. So, you can read here in the help section that we need to create a list data structure. So, that can be done using the list function, just like here, just like what we have done here. So, we are using list function, and the first argument of list function here is to be passed corresponding to the rows, so which is alternatives. So, names of alternatives we have already created. So, the same argument this variable we are passing as the first argument, and then the criteria. So, appropriately dimension names would be picked up from these two variables, alternatives and criteria, which have nothing but the names of alternatives and names of criteria. So, we will get the appropriate dimension name, we will also get the dimensions of the matrix, which is 10 into 7. Now, before we go back to the first arguments, let us talk about this particular argument by row. So, if you look at the description that is given here in the help section, so this is a logical data type, and if false, which is the default setting for this particular argument, the matrix is filled by columns. So, by default, if you do not change this particular argument by row, or do not make it any change into it. So, false, the default value of false would be taken, and the matrix is going to be filled by columns. So, whatever values that we give in the first argument, that is the data part, so they are going to be filled by columns. So, first column is going to be all values would be taken sequentially, and the first column is going to be generated, and once the first column is generated, then second column, so the values in the sequential fashion it will keep on taking, and it will generate the second column and third column, and so on so forth. So, you have to have this clear understanding depending on the kind of matrix that you want, the kind of data that you have, how you would like to fill the matrix. So, this particular argument by row is going to be important in this aspect. Now, let us look at the first argument. So, the example for our exercise that we are taking here, so the numbers you can see in here that we are using C function, combine function, to combine a number of numeric values. Now, here you will see that first we have a number of values which are in similar kind of range, like 1 lakh 3,000, then 1 lakh 1,300, and you can see a number of so almost 10 values are there. So, these 10 values are a similar range. So, actually what we want is because the columns are going to have the criteria name. So, for each criteria we are having the performance numbers for each corresponding alternatives. So, first column we are going to have criteria 1, and for the criteria 1 we are going to have performance numbers for all the alternatives. So, therefore, and these values are indicated here, first 10 values for the same. So, therefore, what we want is we want to we would like to have in the final matrix that is created these values in the column, first column, right. Then next 10 values here you can look at this matrix in the second column. So, if we look at the way we have given the input in our data argument, the first argument, and the way the matrix is being created specifically as indicated by the by row argument. So, we will get the desired output. Had it been the some other way, for example, if the values that we are indicating here that we are passing here as the first argument, data argument, if the values are to be displayed like a row wise. So, whatever values we are indicating, they are to be displayed in a first value is to be given first element in the first row, then the second value will go into the second element of the first row, and so on and so forth. If that was the filling order for the values in the matrix, then we will have to change this argument by row. So, it has to be made true, so that the values are filled row wise. So, however, for our case the default setting is working well. So, we will just run this code and we will get the matrix. So, let us run this. So, now you can see in the output you can see here. So, in the output you can see here we have created 10 by 7 matrix, and you can see these criteria. So, these criteria you can in ASP also, this particular ELECTRE method also, and other techniques also, you can consider typically criteria as we consider variables in our statistical analysis, right. So, these criteria are very akin to the variables that we have, and for each variables and the alternatives we can take an analogy of records that we have when we do statistical analysis. Typically the data that we have is on the column side we have variables, and on the rows side we have records. So, each record and corresponding to variable they are going to have values. Similarly, here we have computed this, generated this matrix, and on the column side we have criteria, and for corresponding to each criteria and each of our alternatives is having one particular number, one particular value, which is indicating its performance with respect to a particular criteria. So, this matrix now we have generated. Now, let us move forward. So, before we move ahead, there is another way through which we can generate matrix. So, just now we have used two function, matrix and combine. So, combine was used to combine the values that we wanted to pass in the matrix function as first argument. Now, there is another way to create this matrix. So, here we can use the Cbind function. So, if you are interested in more details about Cbind function, again you can use this help panel, and you can type here Cbind, and then you will get the help page here, the manual page of Cbind functions. Again, this is also part of the base package. So, you can look at the title, combine all objects by rows or columns, right. So, this is how this function is going to be used. So, here we are using Cbind. So, there is another function called rbind. So, Cbind is if you want to combine by columns, and rbind is to be used if you want to combine by rows. So, here since we are using Cbind, so therefore we are going to combine by column wise. So, therefore, first in this first argument that we have that we have passed here as part of Cbind function, you can see here that first argument is the values which we would like to display in the first column. Then the second argument is consisting of the values which we would like to display in the second column. So, for each of these columns we are using the C function, the combine function, and all of these arguments are then they are presented in this fashion, and Cbind function is going to create a structure, the matrix structure for us. So, let us run this code and you will see a similar kind of output there. similar kind of output can be computed here. So, let us run this much. So, in this script section that we have where we write the file. So, you can select any part of the code, selective part of the code, and if it is a complete code where it can be executed, you can always select that part of the code and you can again press run and you will get the output. So, here if we look at this execution of Cbind function, you can see we have got the similar matrix here. Now, let us go back to the previous code and let us run this, because we wanted to have the dimension names as well. So, now we have the performance table also. So, this particular matrix that we have just created, we are referring this one as the performance we are referring this one as the performance table for alternatives with respect to each criteria. Now, there are certain other parameters that we need to initialize, just like we talked about in previous 2 lectures on ELECTRE, that there are number of technical parameters that we need to specify, that we need to initialize. So, now we are going to do exactly the same in this R exercise. So, we talked about 3 particular parameters in previous 2 lectures. One is indifference threshold, the another one is the preference threshold, and the third one is the veto threshold. So, you can see in the commented lines here, we are going to define thresholds with respect to each criterion. So, again these thresholds are also with respect to the criterion. So, indifference we are indicating typically denoted using Q, the preference threshold typically denoted using P, and the veto threshold typically denoted using V. So, now we have for the initialization we are going to create these variables alpha underscore q. So, this is one which is related to indifference threshold, the beta underscore q which is also related to indifference threshold. So, why we have these 2 variables here. So, these variables these threshold that we create, they can be either absolute or relative. So, if these variables, if these thresholds are absolute, then they are it is we are actually considering the fixed values for these threshold with respect to each criterion. Then in that sense, in that sense only one variable is enough. But if we are defining these parameters, defining these thresholds as relative, so then in that case we will have to create another variable. So, that is why we have alpha and beta, alpha q and beta q, alpha p and beta p, and alpha v and beta v. So, for each type of threshold we have these 2 variables. One is indicating is having the values so that the relative value for each of these threshold can be computed. Now, typically the values that we have in alpha q, they are used to compute the they are there to indicate the relative, how the relative computation is to be done. So, typically this is based on the linear dependence, for example percentage of the percentage of the best performance or percentage of the worst performance. So, if we have something like 0.1 here. So, for example, here you can see 0.1 here in alpha q. So, it could be something like the performance the threshold value is actually 10% of the best performance or worst performance. Now, how do we determine that whether the best performance is to be taken among the among the alternatives or the worst performance is to be taken? For that we have another another parameter which is called mode of definition. So, you can see here in the commented line the mode of definition is indicated. So, this is to be defined for each threshold and with respect to each criterion. So, for each threshold we have to define this. So, you can see here mode of definition, they could be of 2 types, direct or inverse. So, direct is one when we are taking with respect to worst performance, and inverse when we are looking for the best performance. So, based on that the alpha q and alpha p and alpha b are going to be used, the values of these variables are going to be used, and the appropriate modification would be done in beta q, beta p and beta v. So, typically it is the values, because we are generally we take the linear dependence. So, because this is like percentage of something kind of thing. So, typically these values are multiplied. So, you can see in the alpha p q, alpha p and alpha v, the values are in the smaller range between kind of 0 and 1. And if we look at the beta q and beta p and beta v, the values look in the higher range, right. So, these two are multiplied, and that is how we typically compute the thresholds. So, at this point we would like to stop here, and we will continue our discussion, and we will continue doing this particular exercise in R in the next lecture. Thank you.